Alright, now that we've talked about congruent figures, we're going to start talking about our triangle congruence theorem. So we're going to be applying what we know to triangles. So this should be the third page in your congruence figures packet. Okay, so here we have 5 different theorems that we're going to be talking about. Okay, the first 5 all apply to right triangles. Okay, however, this last one, hypotenuse leg, only applies to right triangles. So these first 4, side, 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 angle, side, angle, side, angle, 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 side, apply to all acute and obtuse triangles. Okay, so only hypotenuse leg works for right triangles because acute and obtuse triangles don't have a hypotenuse or technically a leg, I guess you could say. Okay, so our first theorem is a side, side, side congruence postulate. Now this postulate says that if all 3 sides of a triangle are congruent, then the triangles must be congruent. Okay, so in your textbook on page 234, postulate 19, side, side, side congruence postulate says if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. So here we have triangle, let's name this SCH. Okay, and we have to label this triangle the same way. Okay, so here we started with S and we went to C. So here we're going to start with A and R, and then we're going to go to A because this side has 1 hash mark and this side has 1 hash mark. So then we're going to go R, A, and we're going to end with T. Okay, so this has 2 hash marks, this has 2 hash marks, so we're going to follow in the same order as we named our first triangle. So all of our sides and our angles match up. Okay, so here, angle S corresponds with angle R. Okay, this angle is the included angle in between the first hash mark and the third and 3 hash marks. Okay, same on this side. 1 hash mark, 3 hash marks. Angle C, when all 3 sides are congruent, angle C is going to be congruent to angle A. Okay, these are the included angles between our first side here with 1 hash mark and our second side with 2 hash marks. Same on both. Angle H is going to correspond with angle T. Okay, so our side, side, side postulate tells us that if all 3 of our sides are congruent, then all of our parts within this triangle are congruent as well, so we can match up our angles. Okay, now let's name our lines. RA has 1 hash and SH has 1 hash. Okay, notice I started with R and S. Okay, these are congruent angles, and A and C are also congruent angles. Let's look at AT. Okay, this is line AT, so I'm starting with this angle and I'm going to angle T. So when I match these up, I have to start with angle C and end with angle H. Same thing for side TR. Okay, I'm starting with T and I'm going to R. So I'm going to start with H and I'm going to go to S. Notice at the bottom of your packet how it says corresponding parts of congruent triangles are congruent. We're going to look at this a little bit later, but it's called CPCTC. Okay, so when we have corresponding parts of congruent triangles are congruent, that's pretty much just saying since all of our sides are congruent, we know that all the corresponding parts must also be congruent. So that's why we can name our angles, we can define which ones are congruent, and our sides. Now we're going to look at side angle side. This is on page 240 of your textbook. The side angle side congruence postulate says if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. Now that included angle part is key, okay? So this, let's uncover it. This should say included. Let's see if I can write this in. Okay, now if you look at our picture, we have two sides, and these are our included angles. If, let's say, we chose to use angle B and angle S, we cannot use side, angle, side, okay? Because this would be angle, side, side. And that's not a theorem or postulate that we're going to be using. Okay, so this included angle is crucial. So we have two sides and it's included angle. We'll talk more about this in class, but I just wanted to point that out. Okay, so here we have triangle, let's call this BYE. Okay, so we started with B, we went to Y, and then we went to E. So now with this triangle, I'm going to start with SCH. Okay, so by side, angle, side, now I know that all my angles in here are going to be congruent as well. So let's look at angle B. Angle B is going to be congruent to angle S. Okay, they're both connected to this line that only has one hash mark. Okay, Y, we're already given that Y and C are congruent. And then we also have angle E. Okay, angle E is going to be congruent to angle H. On the right side of each angle, we both have this line that has two hash marks. Okay, now for our lines, here we have, let's see, we're looking at SH. Okay, SH, this has one hash mark, BY has one hash mark. Okay, I'm labeling it from B to Y because that's how we labeled it for SH. CH, okay, I'm going to label it as YE because Y is congruent to C and E is congruent to H. So we have to be careful to how we're labeling these lines. We have to make sure that the corresponding parts line up with each other. And finally, SH and BE, line BE are congruent. Next we have angle, side, angle. On page 249 of your book, the angle, side, angle congruence postulate is stated. It says if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two angles are congruent. So here, this should say included. Okay, so we have two angles and the included side. Okay, same goes for this postulate, just like side, angle, side. So we have to make sure that this side is included between the two angles. If we're saying that these two sides are congruent, here we have angle, angle, side, and that's not what we're talking about. We're talking about angle, side, angle. So make sure you're paying attention to detail because we couldn't prove that these triangles are congruent the other way. Okay, so let's call this first triangle MIS. Okay, so I'm starting here with my first angle, going to my double hashed angle, and then ending with S. So here I have to start with my single hashed angle Y. I'm going to my double hashed angle O, and I'm ending with U. Okay, so we're showing that these angles are congruent. All the parts are congruent to each other. By angle, side, angle. By angle, side, angle, then we can go ahead and fill in the rest of these, the other corresponding parts of the congruent triangles. Okay. So now by angle, side, angle, I went and filled everything in. I'm going to start with angle M. Okay, angle M is going to be congruent to angle Y. Angle I is congruent to angle O. And angle S is going to be congruent to angle U. Alright, let's look at line MI. MI is going to be congruent to YO. IS is going to be congruent to OU. And line MS is going to be congruent to line YU. Next we have angle, angle, side. Now angle, angle, side can get a little tricky. On page 249 of your textbook, our angle, angle, side congruence theorem says that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. So this one we had to be a little careful because our last postulate said that two angles and the included side, which was angle, side, angle. Now we have angle, angle, side. So now we're talking about this non-included side here. Okay, so this should say non-included. Okay, if we have two angles and a non-included side congruent, which we do, okay, we have angle, angle, side, angle, angle, side, and they all match up, then we can say that the rest of these parts are congruent as well by CPCTC. Okay, so I'm just going to go ahead and fill all these in. Match everything up with each other. So let's call this triangle ACL. Okay, ACL. So this triangle is going to be called OSR. I'm lining up all of my angles with each other. Okay. Angle A is going to be congruent to angle O. They both have 3 arcs on them. Angle C is going to be congruent to angle S. They have 2 arcs. And angle L is going to be congruent to angle R. They have 1 mark. Okay. Side AC is going to be congruent to OS. They have 2 hash marks. Notice that I'm labeling it correctly. Okay, I'm going from this angle to that angle and this angle to that angle. I'm saying consistent. Okay, next I'll name CL is going to be congruent to SR. And lastly, LA is congruent to RO. Okay, so alright, and our last, this is a theorem, hypotenuse leg. One leg and a hypotenuse of a right triangle are congruent. This only applies to right triangles. Alright, so let's go through and label everything that we got. Okay, here I have my triangle is going to be called BES and TMA. Okay, I have a hypotenuse and a hypotenuse congruent. I have a leg and a leg congruent. Okay, and it's a right triangle. So I can go through and I can name all these other angles and sides congruent. Okay, you could also use this as a leg. It doesn't matter which leg you're going to use. So you're going to have B is congruent to T, E is congruent to M, and our right triangles, S is congruent to A. I also labeled that in my triangle. So the last angle that I ended with, S and A, are my right angles. Okay, so let's name my sides. BE is going to be congruent to TM. Side ES is going to be congruent to side MA. And lastly, side BS is going to be congruent to side TA. Okay? Tomorrow in class, we're going to be talking about this side-side angle and how it relates to triangles that are not right triangles. Okay? So now this concludes your packet. On the back, you should have proofs, and we're going to do those together as a class.